lesson. And so we're going to have a case where we have angle A and angle B that are acute. And I'm given that the tangent of A is 11 over 12, and I want to find the cosine of A. So for a question like this, we have to remember that tangent is opposite over adjacent. And I'd like to attempt to make a sketch of this situation. So let's just go ahead. Let's say we have angle A over here. Okay, so here's my opposite and here's my adjacent. So this needs to be 11 over 12. Okay, now cosine. So cosine is it's going to be the adjacent over the hypotenuse. And it turns out I've got the adjacent, but I don't have the hypotenuse. So I need to solve for that. And I'm just going to call this C, because it is kind of like the Pythagorean theorem. So I can say C squared equals A squared plus B squared. So we're just setting up Pythagorean theorem. So C is going to be the square root of 11 squared plus 12 squared. And that just comes out to 265. Now I'd like to see if I can reduce this square root a bit further. So factors of 265, I want to see if one of these happens to be a perfect square. I've got 1, 5, 53, and 265. So I don't have that. I'm just going to leave it as square root of 265. So the cosine of A is my adjacent side, which is 12, and that's going to be over the hypotenuse, which is the square root of 265. Now, we are not considered simplified fully if there's a square root in the denominator. So the way to make that go away is I'm going to multiply by square root of 265 over the square root of 265. That'll cause this to become a whole number. So we don't have the root in the denominator anymore. So I'm going to have 12 over the 12 multiplied by 265, square root of 265, divided by 265. That's the cosine of A. So let's make sure that we've answered the question. So the tangent is 11 over 12. The cosine is going to be 12 times the square root of 265 over 265. Okay, so let's continue on to our next question. So we're asked to find the missing angle, and the missing angle in this case is theta. Now you're going to need a calculator, okay, and you should have certain inverse functions on the calculator. I'm going to show you that in just a moment. But first of all, let's see what we have. We've got the opposite and the adjacent sides right here. So I can say that opposite and adjacent is tangent. So the tangent of theta is 10 over 4. And now this next step, if you'll look on your calculator, okay, you'll have a button that says tangent. You need another button which is going to say, it's going to look just like that. Okay, that is inverse tangent, and we're going to need that to solve this. Okay, so the next step in this question, bear in mind I'm solving for this angle. Okay, so we're going to say that theta equals the inverse tangent of 10 over 4. Now this is just done in the calculator. So I'm going to put that in my calculator, and then I'm going to round it to the 10th place. Okay, so 1 decimal place, and I get theta equals 68.2. Okay, so we can go ahead, label that 68.2 degrees, and we're finished with that question. Now my next question, this time I have a missing side. okay? So I need to consider what I have and what function I'm going to use. So I've got angle A as 48 degrees. I have the adjacent side, and I have the hypotenuse. So adjacent and hypotenuse, I can use cosine. So the cosine of 48, it's my adjacent side divided by the hypotenuse. Okay, so what I'm going to do to solve for x, I'm going to essentially multiply by x on both sides of my equation. So that's going to cancel out. I'll have x times the cosine of 48 equals 7. So now if I divide by the cosine of 48 on both sides, I'll have x isolated. So we'll have x equal to 7 over the cosine of 48. Now, the last part, this has got to be done in the calculator. Okay. So I'm going to put that in my calculator, and I'm going to round to the nearest tenth, and that gives me 10.5. Okay, so I've answered the question. I can come up and label it here also. So that side is 10.5. And this concludes the second lesson. Hopefully you've already downloaded the note that's posted in the description.